Welcome to part 13 of Applied Chemistry, where we'll discuss about hazardous waste and their treatment. Hazardous wastes are materials that pose a potential risk to human health or the environment due to their chemical, biological, radioactive, or physical properties. In this section, we will classify different types of hazardous waste and examine various physical, chemical, and biological treatment methods, along with safe disposal practices. Hazardous waste can be divided into several categories. Radioactive waste. This waste is produced from nuclear reactors, laboratories, and hospitals. It contains radioactive isotopes that emit harmful radiation and can persist in the environment for thousands of years. Examples include nuclear fuel rods, radioactive medical waste, and contaminated equipment. Biomedical waste. Generated from healthcare facilities like hospitals and laboratories, this waste may be infectious, toxic, or harmful. It includes used syringes, contaminated bandages, blood bags, and pharmaceutical waste. Hazardous waste also includes chemical waste. These are wastes from industries, laboratories, or households that contain toxic, corrosive, or flammable chemicals. Examples include pesticides, solvents, acids, batteries, and cleaning agents. Biological waste. This type of waste includes materials contaminated by living organisms, often from medical or agricultural sources. Examples include animal waste, genetically modified organisms, and biological research materials. Toxicity is a key characteristic of hazardous waste. Toxic wastes are harmful when ingested, inhaled, or absorbed through the skin. These substances can leach into soil, groundwater, or surface water, posing significant health and environmental risks. Examples of toxic waste include heavy metals like lead, arsenic, and mercury, as well as pesticides and carcinogenic chemicals. Toxic waste can lead to severe health effects such as cancer, birth defects, and organ failure, while also contaminating ecosystems. Another important classification is ignitability. Ignitable wastes can easily catch fire under normal conditions, with a low flash point. Examples include gasoline, alcohol, paint thinners, acetone, and certain oils. Fires caused by ignitable waste can release toxic fumes and cause explosions, posing significant danger during storage and transport. Reactivity refers to wastes that are unstable under normal conditions and may cause explosions or release toxic gases when exposed to water or other substances. Examples include peroxides, explosives, cyanide, and lithium-sulfur batteries. These reactive wastes require specialized containment and handling due to their dangerous nature. Corrosive wastes are highly acidic or alkaline, with a pH of 2 or lower or 12.5 or higher. These wastes can corrode metal containers, equipment, and structures, leading to leaks or containment failures. Examples include sulfuric acid, hydrochloric acid, and sodium hydroxide. Corrosive wastes can cause severe skin burns, respiratory damage, and harm aquatic life when released into the environment. Hazardous waste treatment involves various methods to reduce the risk of contamination, prevent exposure, and render the waste less harmful. The treatment processes are classified into physical, chemical, and biological methods. Let's discuss the physical methods for treating hazardous waste. Encapsulation. This physical process involves surrounding hazardous materials with an inert barrier such as concrete or polymers to prevent contaminants from leaking into the environment. It is especially effective for long-term disposal. Filtration is used to separate solid hazardous waste from liquids. Filtration is commonly applied in industrial wastewater treatment. However, it is only effective for certain types of solid-liquid mixtures and requires further treatment for residual waste. Chemical processes include neutralization. In this process, acidic or alkaline wastes are treated with chemicals to bring the pH to neutral. This is commonly used in industries that deal with chemical byproducts, making waste easier to handle and less dangerous. Precipitation. Chemicals are added to waste to form insoluble compounds, which can then be separated as solids. This is particularly effective for removing heavy metals like lead, chromium, and mercury from industrial wastewater, but it generates sludge that must be properly disposed of. Other important chemical processes are oxidation and reduction. Oxidation involves adding oxygen or an oxidizing agent to break down hazardous organic chemicals into less harmful substances. Reduction involves adding a reducing agent to convert toxic substances into less harmful forms. Both methods are effective in treating organic pollutants and toxic chemicals, such as cyanides, though they may produce byproducts that require further treatment. Biological processes for hazardous waste treatment include bioremediation. This method uses bacteria, fungi, or other microorganisms to break down hazardous organic materials into non-toxic byproducts. Bioremediation is environmentally friendly, cost-effective, and can often be done on-site. However, it takes longer than other methods and is only effective for organic waste. Once hazardous waste has been treated, it needs to be disposed of in a safe manner. For the disposal of hazardous waste, one method is secure landfilling. Hazardous waste is disposed of in specially designed landfills, which have impermeable liners to prevent the escape of leachate and contaminants into the environment. Secure landfills are effective for long-term containment, but they require careful monitoring and maintenance to prevent leaks. Another disposal method is deep well injection, where liquid hazardous waste is injected deep into porous rock formations below groundwater levels. This method is commonly used in industries like petroleum refining and chemical production. It isolates waste from the environment and can handle large volumes of liquid waste, though geological suitability is essential to prevent contamination risks. Incineration is used to burn hazardous waste at high temperatures, breaking it down into ash, gases, and heat. This process significantly reduces waste volume and destroys toxic substances. However, it is expensive and requires specialized equipment to control emissions, such as dioxins, that can be harmful if released into the atmosphere. In summary, hazardous waste includes radioactive, biomedical, chemical, and biological waste, each with distinct risks. Hazardous wastes are classified by characteristics like toxicity, ignitability, reactivity, and corrosivity, which determine how they should be handled and treated. Treatment methods include physical processes like encapsulation and filtration, chemical processes like neutralization and precipitation, and biological methods such as bioremediation and phytoremediation. Disposal methods include secure landfilling, deep well injection, and incineration, all designed to safely contain or destroy hazardous waste. We've reached the end of this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on applied chemistry and other exciting topics.